Hello everyone, this is SP Gubbi online classes for mathematics and science, especially for 10th standard SSLC and Cbse. So in the last session of light, I had discussed regarding the mirror formula, which was a very important derivation which was done. I hope you enjoyed the entire session. So a sample of that is the similar triangles concept was also introduced in the beginning of that. So it is very important. So 1 by f is equal to 1 by u plus 1 by v. So that's called the mirror formula. So 1 by the focal length of the mirror is always equal to 1 by the object distance plus 1 by the image distance. So that is numerically written as 1 by f is equal to 1 by u plus 1 by v. So that is what we call the relationship between u, v and f in case of mirrors. So this mirror formula is applied for all type of mirrors, that is including concave mirrors as well as convex mirrors. So that was a very important derivation. I hope you have all learnt it, and in the next classes, that is in the next session, as we are going with the numericals connected to the mirrors, so it will be a lot of use for you and it will become very easy for you. Right. So in today's session we will be going with the most important another concept of light, that is regarding mirrors, that is linear magnification in mirrors. So after that we will be going with linear magnification of concave mirrors. So we will be along with some 2 to 3 formulas. I will just correlate between the formulas and give you a clear idea for the numericals which are coming in the next session. So in today's class, let us get into linear magnification in mirrors. So this is linear magnification in mirrors. So very important, right? So linear magnification means the linear magnification of a mirror is the ratio between the size or height of the image of the object, the size or height of the image of the object to the size or height of the object, So this is the ratio. The ratio we call it as linear magnification in mirrors, which is represented by small letter m always. So the ratio, that is linear magnification, is indicated by small letter m. So it's the ratio between size of object is to size of image is to size of object. So this can be written as m is equal to size of image is represented by h dash always. So size of object is represented by h. So therefore m is equal to h dash by h. So this is the linear magnification in any type of mirrors. It is applicable for both concave mirrors as well as it is applicable for convex mirrors. So this linear magnification for plane mirrors will be equal to 1. So that is, we have to remember this. So linear magnification in plane mirrors. Linear magnification in plane mirrors will be equal to 1, exactly 1, because the size of the image will be equal to the size of the object, that is in case of plane mirrors. So linear magnification in a plane mirror is always equal to, plus 1 is better thing. So it is plus 1, and in case of other 2 mirrors, that is curved mirrors, concave mirror or convex mirrors, the linear magnification will be the ratio between the size of the image to the size of the object. This ratio, the name given for this ratio is linear magnification in mirrors, and that is represented by a small letter m. So here, linear magnification of mirrors is applicable for both the mirrors, and it doesn't have any units for this. It doesn't have any units. Right. So in this magnification, we go for positive magnification. Very important. Positive magnification. So here, what do you mean by positive magnification? Means magnification may be positive or negative. It doesn't have any units, but it can be positive or it can be negative. So when does magnification become positive? The magnification of a mirror becomes positive when both the object, just imagine a mirror, this is the principal axis, the object is on the principal axis and the image of the object is also on the principal axis, that is above the principal axis. When this happens, we say that the magnification of that mirror is said to be positive. Something like this, we had come across a mirror like this, a concave mirror. The object was placed, this is the principal focus, this is the pole, this is the center of curvature. The object was placed here. I hope you remember the sixth ray diagram in case of concave mirrors. So the object was placed between F and P. We got a enlarged image of that object. So here the object is above the principal axis, which is positive. The image is also above the principal axis, which is positive. So therefore, in this case, when you take the ratio between the height of the image to the height of the object, then we get positive by positive. So therefore, magnification becomes positive. So this is the case. So when do we say that magnification is positive? We say that when the object is usually in case of any mirrors, we cannot keep the object below the principal axis. The object is always kept above the principal axis. So that will become positive. That is, anything what we measure above the principal axis is positive. When you get the image of that particular object, and that image also will be situated or placed above the principal axis, then that will also be positive. So if the image is said to be above the principal axis, that image will be 100% a virtual image and an erect image. So therefore, for those ray diagrams where we get the image above the principal axis, those mirrors, so you will be having positive magnification. So here in this case, you can easily see here, this is positive, this is also positive. So positive divided by positive, that is, this positive divided by this positive will give you positive value of m. So therefore, magnification is said to be positive. This is how we have to take. So next is negative magnification. Negative magnification. So here, what is negative magnification? When do we call the magnification m, or when does m become negative? That's very simple again. So here you can go with a ray diagram again in case of a concave mirror. So this is a concave mirror. This is center of curvature. This is the principal focus. This is the pole of the mirror. So if I keep the object beyond C, that is the second ray diagram what we had done in the case of concave mirrors. When we place the object beyond C, so let us take it as AB. So this will be positive because it is above the principal axis. So here the image will be formed between C and F, which is diminished. We know that. So that is A dash and B dash. So here this is positive and this is negative. So magnification is nothing but the ratio between the height of the image to the height of the object. So height of the image is negative here and height of the object is positive here. So m is equal to h dash by h when we take. So h dash is negative and this will be positive. So a negative value divided by positive value will be a negative value. So therefore here magnification is said to be negative. So usually in a ray diagram or in those mirrors where we get real images, so those mirrors, real images when we get, we say the magnification of magnification is of that mirror is said to be negative. So two conclusions we can come here. If you draw a ray diagram and if the image what you get is above the principal axis, that is, if it is a virtual image, then the magnification is said to be positive. If in the case for a mirror, if you draw a ray diagram, if you get the image below the principal axis, that will be negative and that magnification will be negative for that mirror. So it's very simple here. So here positive by positive is positive magnification, that is m plus, or negative by positive, that is minus that is minus by plus you get, so magnification will be negative. So negative magnification. So magnification of a plane mirror will neither be positive nor be negative, it will be just equal to 1, right? So, or in the case you can take linear magnification of a plane mirror is also positive, no problem in that. So once again I will repeat, linear magnification in mirror means it is the ratio between the size of the image to the size of the object, that is represented by the small letter m. So m will be equal to h dash by h. So magnifications may be of two types. If in a ray diagram, in a situation, if you get a virtual and erect image, then the magnification is said to be positive. If in a case of a mirror, if you get a real image, then the magnification is said to be negative. And in the third case, for a plane mirror, magnification is positive and it is equal to exactly 1. So these are the points you have to remember regarding magnification. So now let us go with magnification in a concave mirror. Magnification in a concave mirror. This is also very important, a small derivation. So we will derive the formula for this, and after this we will correlate the mirror formula, magnification formula, and the formula what we get now from magnification of a concave mirror. So we will relate all these three formulas, and including this we have another very small formula, that is focal length is always half the radius of curvature of the mirror. So that simple formula, so all the four formulas are including, and keeping the knowledge of theory what we have, we will go with the numericals. So numericals are very challenging for a student. If he knows the theoretical background and all the formula derivations, and if he can recall a particular formula when required, he will become a master in that. Okay. So magnification in a concave mirror. So now let us take a concave mirror here. So it is silvered at the outer surface, so that its inner surface is reflecting. So this is the pole of the mirror. So we will draw a line through the pole, and on it we will mark the center of curvature. This is the principal focus. So this distance should be equal to this. This is the principal axis. So now we will keep the object beyond C. Beyond C we will keep the object and call it as AB. So from point A we need minimum 2 light rays starting from point A. So now one light ray we will take it as parallel to the principal axis. It is travels parallel to the principal axis. Any light ray traveling parallel to the principal axis passes through the principal focus. So this is the reflected light ray. We will take it as point M here. And we will make another light ray to pass through the principal focus itself. So any light ray traveling through the principal focus after reflection from the mirror starts traveling parallel to the principal axis. So here actually the two light rays meet. So this is the reflected light ray, this is the reflected light ray, they meet at this point. So where the two real light rays meet, there we say that a real image is formed, and real images are always inverted. So this is the point where the image is formed. Let us call it as A dash, and we will call it as B dash. Okay. So these are the two things with us now. Now the object is placed perpendicular to the principal axis. We will take this, and the image is also formed perpendicular to the principal axis. So this will be equal to 90 degrees. And very important thing is, in this triangle, that is ABF, in this triangle particularly, we have AB, the height of the object, which is represented by H. So this is principal, that is focal length, which is represented by F, and this is the object distance, that is BP is the object distance. So BP is equal to AM. BP is equal to AM because here as the aperture of the mirror is very small, M and B meets each other. So let us draw a line, dotted line here. So here PB is nothing but equal to AM. So PB is actually the object distance that is represented by U. So AM also becomes U. So this is the object distance. So here again B dash P. B dash P here also is the image distance. B dash P is the image distance which is represented by V. But B dash P is equal to A dash N somewhere here, because P and N coincide, because the aperture of the mirror is very small, P and N meet. So therefore this length I am going to take it as V here. Okay. Now triangle ABF, and when we try triangle we will do one thing. I will just make it still more easier. Let the second light ray pass through the pole itself. So it will be easy for our derivations. This is the reflected light ray, that is AM. This is the another light ray striking at the pole of the mirror. So it is going to reflect back somewhere here. So this angle will be equal to this, because this is the angle of incidence and this is the angle of reflection. So angle of incidence will be equal to angle of reflection here. So it's very simple. So here the point at which the two light rays meet is the point where the image is formed. So it is A dash and this is B dash. So now let us take two light rays, two triangles now. So in triangle AB, okay, now we will have to take this as V. So this is the distance between the pole and the image, that is taken as V. We will take it as V. This is the distance, and usually this is U, this is H, and this will be H dash. This will be H dash. Alright, now it's very clear. Now we will select two triangles. One is triangle ABP, another is triangle A dash B dash P. We will take these two triangles. ABP is one of the triangle and A dash B dash P is another triangle. So according to the knowledge of similar triangles what we have learned in the yesterday's class, we will apply that. So in triangle ABP and triangle that is A dash B dash P, A dash B dash P. In these two triangles you can see angle ABP, this one is 90 degrees, and angle A dash B dash P, this is equal to 90 degrees. So angle ABP is equal to angle A dash B dash P. So both are 90 degrees. Okay, then angle APB, so this angle is equal to angle B dash P A dash or A dash P B dash. So that is this angle. So because the incident light ray is incident on the pole of the mirror, so it gets reflected as though this pole acts as a plane mirror. I had told you in the previous classes. So therefore angle of incidence, this principal axis acts as a normal. So the angle between the incident light ray and the normal is the angle of incidence, and the reflected light ray and the normal, this angle is called the angle of reflection. So according to the laws of reflection, both the angles are equal. So therefore angle APB will be equal to angle A dash P B dash. A dash P B dash. So that is angle I is equal to angle R. Angle of incidence will be equal to angle of reflection. So in these two triangles, two pairs of corresponding angles are equal. So in two triangles, if two pairs of corresponding angles are equal, then the triangles are equiangular. If two triangles are equiangular, no doubt they will be similar. If two triangles are similar, then their corresponding sides are proportional. So now we will write the similarity, or we can go like this: triangle ABP and triangle A dash B dash B are equiangular. They are equiangular. Therefore, triangle ABP is similar to triangle A dash B dash B. So, according to the AA criterion. According to the AA criterion. So, if two triangles are similar, then their corresponding sides will be proportional. So, now let us take the proportionality. So, we will take in the first triangle, we will identify the third angle. So, this is 90, this is angle I, and this is the third angle. I am going to represent that by a dot. And in this triangle, this is 90 degrees, and this is the angle of reflection. So, this becomes the third angle. So, now we will select two sides which are opposite to these two angles and opposite to the third angles. So, we will go with the first, start with the first triangle. So, the side opposite to the third angle is, that is B dash P. B dash P. B dash P by third angle opposite in case of the triangle ABP. In triangle ABP, this is the third angle, opposite to that is BP. So, BP is nothing but the object distance. So, that is, okay, write BP here. So, this is B dash P. B dash P is for this triangle. So now we will go with the sides opposite to the angle of incidence and reflection. We will take the angles opposite to that of the angle of incidence and angle of reflection. So in this angle opposite, the side opposite to angle of reflection is A dash B dash, that is okay, A dash B dash by, and in ABP triangle opposite to this angle, that is angle of incidence, is AB. That is AB. So reason is corresponding sides are proportional. Corresponding sides are proportional. Now we will put the values for this. So let us write what is B dash P. So here B dash P is the image distance, that is V by, what is BP? BP is the object distance, so that is represented by U, is equal to A dash B dash. A dash B dash is the height of the image, that is H dash, by the height of the object, that is AB, that is H. So now we will apply sign conventions, Cartesian sign conventions, what we had discussed in the previous session, to the values what we have got. So here V is V, that is nothing but the distance between the pole of the mirror and the image. So V is being measured against the direction of the incident light rays, so therefore that is taken as negative. And U is the object distance, so object is here, you are measuring from here, so therefore you are doing something against the light rays, therefore it is taken as negative. So H dash is below the principal axis, so therefore it is taken as negative, and H is above the principal axis, therefore it is taken as positive. It remains positive. Right. So we will go with the next step. I will carry this minus V by minus U is equal to minus H dash by H. Minus minus cancels. So V by U is equal to minus H dash by H. So we will multiply both sides by negative sign. So minus of V by U is equal to minus of minus H dash by H. So minus into minus is plus, plus H dash by H is equal to minus into plus V by U is minus V by U. So this is the relation we have got now. So here, just now in the previous topic, we had discussed that magnification M is equal to H dash by H. We had discussed M is equal to H dash by H, that is the ratio of the image, the height of the image to the height of the object is called as the magnification. Now let us relate this. M is H dash by H, but H dash by H is minus V by U. So therefore, from from this equation and this equation, I can write m is equal to minus v by u. So this is the magnification formula for a concave mirror. This is the magnification formula. So we have three formulas here. One is 1 by f is equal to 1 by u plus 1 by v. This is called mirror's formula. H dash m is equal to h dash by h. This is the magnification of a mirror. So m is equal to minus v by u. This is the magnification of a concave mirror, and we can easily equate this. H dash by h is always equal to minus v by u. So these are the formulas you have to remember whilst before solving the numericals. Along with this, you should be very good in the sign conventions, that is Cartesian sign conventions, where to apply signs and where not to apply signs. So one small note I am going to give you now. You have to please remember this. So many students do silly mistakes here. 1 by f is equal to 1 by u plus 1 by v. In this case, there are three elements, that is f, u and v. So in numericals, what happens is two values will be given and you will be asked to find out the remaining value. For example, if they give you u and v, they will ask you to find out f, something like that. So in this case, what you have to remember is what the data you have. For example, you have the value of u and you have the value of v. Apply those values, and if they are negative, if they are positive, whatever it is, you apply it. But for the unknown, what you are going to still find it out, do not put any signs in their places. This is a very important note. For example, if you know that f becomes negative, don't put the sign at the beginning itself. So when the answer comes, it will come by itself the right answer. With the sign, it will come back. So don't put the sign for the unknowns in numerical problems while solving problems on mirrors, but particularly, especially, you have to be very careful. So you have to remember these things. So 1 by f is equal to 1 by u plus 1 by v. M is equal to h dash by h. M is equal to minus v by u. H dash by h is equal to minus v by u. And when do you get positive magnification and when do we get negative magnification? And we know that the magnification of a mirror is plus 1. Right? So these are the things in this session. So in the next class, we will be going with beautiful numerical problems. I will help you to understand the problem with a ray diagram for each and every numericals. Right. So I hope you enjoyed this entire session. So read the textbooks, practice ray diagrams. You have 8 ray diagrams for your exams, 6 from concave mirrors and 2 from convex mirrors. So all the ray diagrams are important. Please try to very clearly understand the sign conventions, that is Cartesian sign conventions. Our mirror formula, we should remember this, recall this, and the magnification formulas for linear magnifications and magnification for concave mirrors. So these are the things you have to remember, right? So stay home, stay safe, keep learning. Thank you.